ChatGerry, Math Physical Medicine, Wave Theory Approach to My Glucose Big Data. Paper number 1349, Gerald C. EclaireMD Foundation. Category, Diabetes. Abstract. Since 2014, I have been recording 96 glucose points every single day, one every 15 minutes. Over 12 years, that adds up to more than 420,000 data points. With such high density, I can no longer treat glucose as just a number on a lab slip. I now see it as a wave system, moving dynamically across multiple time scales. In this report, I describe how I use three tools: fast Fourier Transform, FFT, Wavelet Transform, WT, and Empirical Decomposition, EMD, to uncover hidden rhythms in my data. I then map them into my Viscoplastic Medicine Theory, VMT, energy model to connect wave properties with the real metabolic energy damage happening inside the body. From this analysis, I found strong links between fasting glucose, FPG, body weight, and sleep, a predictable 3-hour cycle in postprandial glucose, PPG, and the hidden dangers of nighttime hypoglycemia when using diabetes medications. These wave-based insights reveal risks that conventional medical statistics often miss, and they point toward a new way of thinking about personalized chronic disease management. Why averages fail us. Conventional diabetes care leans heavily on HbA1c, a 90-day average of glucose, or population regression models, but averages flatten out what really harms patients. The extremes, hyperglycemia, ultra-high glucose, silently damages organs and triggers long-term complications. Hypoglycemia, ultra-low glucose, can cause seizures, coma, or sudden death. Neither risk is visible in HbA1c. This is why I say medicine's obsession with averages is a dangerous loophole. What matters is the wave pattern, the ups, the downs, and the timing. My big data journey. Over 12 years, I have built what I call a living laboratory of more than 420,000 glucose measurements. My body is my lab, but its rhythms are similar to millions of others. With this dense dataset, I can use tools from physics and engineering to detect patterns that medicine typically ignores. FFT shows me dominant rhythms, such as 1 cycle per day, circadian, and 3 cycles per day, meals. WT shows when those rhythms appear or disappear, such as sudden bursts during stressful weeks or travel. EMD lets the data speak for itself, peeling apart the raw signal into intrinsic mode functions, IMFs, the fastest oscillations, the daily cycles, and the long-term trend. I am not here to reteach math. Fourier, Wavelet, and EMD methods are well established. My contribution is showing how they apply to biomedical big data and how they fit into my VMT, energy framework for measuring health risks. What I found. 1. Fasting plasma glucose, FPG. My quarterly FPG at wake-up closely tracks my quarterly body weight, approximately 89% correlation, and sleep hours quality, approximately 77 to 78%. Better sleep and lower weight stabilize my fasting glucose. 2. Postprandial glucose, PPG. After meals, my glucose follows a predictable 3-hour wave. A peak at 1 hour, a valley at 2 hours, then a small tilt upward. Peak height depends on how many grams of carbs and sugars I eat. Valley depth depends on how much I walk. I usually take about 4,000 steps after meals. The final tilt depends on leftover energy balance, intake minus burn. 3. Medication effects. I avoid snacks after dinner to reduce nighttime surges. After my stroke in June 2025, I restarted metformin. I learned quickly that I must monitor carefully, because during sleep my glucose can fall below 70 mg per deciliter. After 15 years without medication, my body became highly sensitive to hypoglycemia once I resumed drugs. Why this matters? Population guidelines serve their purpose, but they miss what really endangers individual patients: instability. HbA1c and averages ignore the sharp swings that define a patient's daily life. My wave theory reframes diabetes, like other chronic diseases, as a nonlinear, dynamic, and irreversible system. Instead of focusing on static numbers, I measure the energy damage from repeated glucose swings. This idea matches what we know about vascular stress, oxidative damage, and metabolic overload, but I can track it in real time. I often ask, why has medical research overlooked such powerful tools? If the goal is to save lives, we must move beyond averages and adopt dynamic, wave-based, energy-based analysis. Conclusion: glucose is not just a number, it is a living wave. Meals, sleep, weight, exercise, medication, and stress all shape its pattern. By applying FFT, WT, and EMD to my 12 years of dense data, I can see daily, weekly, and seasonal rhythms that link directly to health risks. When integrated into my VMT framework, these rhythms expose cumulative metabolic damage and show practical paths to stability. Most importantly, they remind me, saving lives Depends on catching extremes and fluctuations, not celebrating averages. Disclaimer: this content is for educational reference only and not medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be edited or republished as your own.